Hi, I'm submitting this assignment as the final project, course project for the Machine Learning Foundation for Project Managers on Coursera. As part of the project, we are supposed to go through the data and model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbine, steam turbine, heat recovery system to generate the power. So we have in this data set of 9568 hourly average ambient environment readings for different sensors of the plant, and we have to predict the full load electrical power output of the power plant to maximize the profit from the available megawatt hours. The base load of the operation of the plant is informed by four main parameters which are used as the input data. These are the ambient temperature, atmospheric pressure, relative humidity, and exhaust stream pressure. So first thing portion is the modeling approach. So these four items we are taking in the combined cycle plant composed of gas turbine, steam turbine, and heat recovery generator. So we need to use this data to generate the output. So the objective of the project is to predict the full load, the electrical power output of the base combined cycle power. Here I have used polynomial multiple regression, and also I've used cross validation to find the most hyper input. In project also I have used clustering to demonstrate the relationship between the variables and use of lasso for dimension reduction. So first just quickly let me take you tiles. So here first we have used the output and we have tried to see the negative and positive correlation from the project. Here we have a strong negative correlation power with ambient temperature exhaust vacuum. So it seems the temperature and or volume increases the power output of the plant area. Similarly, power has a positive correlation with pressure and humidity. It seems that on increasing humidity, the pressure, the power output will increase. Vacuum has a strong positive correlation with temperature of the plant, and also humidity has a small positive correlation with pressure. So all other non-power linkages have a negative correlation. So we have done here clustering, and from there we have taken the output. As we are seeing from the clustering diagram, the knee appears at 4 to 5 clusters. Also we have seen the silhouette analysis for the different cluster, and the silhouette analysis shows that at 2 clusters the silhouette is the best. Also we have done a box plot here to understand the different functions, and observation is powerful cluster 0 is higher than cluster 1, and humidity and pressure distribution higher level for cluster 0 than cluster 1, suggesting that the increase power, humidity and pressure should also be increased. Also temperature and vacuum are on lower level for cluster 0, such like that for higher level of power to be generated, the plant temperature and vacuum level should be as low as possible. Also we have done the data set using lasso and to see what is the kind of validation that we are getting. So I've done bootstrapping in order to assess the accuracy of the model on the test data set. So finally, we have seen the clustering which are responsible for the output suggests that increased power, humidity and pressure should be increased, and high level of power to be generated. The plant temperature and vacuum level should be as low as possible. Tenfold cross validation helps in finding the most optimum degree for polynomial regression and level of alpha for the lasso model. And lasso shows that what are the parameters which are important to the model, and bootstrapping reflects a confidence interval. So when we are taking the confidence interval R square, we are seeing that the 95% confidence interval R square at 92.7 and 92.9. So by tweaking this parameters using cross validation and applying lasso for getting the most important dimensions, this model is able to achieve an accuracy of around 92.7 and 92.9 for the test data. Thus we can see that this model is for predicting is high accuracy what would be the power output of a combined cycle power plant. This can substantially bring down the cost of production by controlling the input parameter of the plant and lead to an increased efficiency.